Assessing criticisms of renewable energy. Renewable energy has gained significant attention as a promising solution to address the growing concerns related to climate change and environmental degradation. While there is a broad consensus on the need to transition away from fossil fuels, some critics argue that renewable energy sources are not as effective or sustainable as proponents claim. In this chapter, we will examine various criticisms leveled against renewable energy and assess the validity of these concerns. Intermittency and reliability. One common criticism of renewable energy sources, particularly solar and wind power, is their intermittency. Critics argue that these sources are not consistently available, leading to challenges in maintaining a reliable energy supply. Indeed, solar power is dependent on sunlight availability, and wind power relies on wind patterns, both of which are variable. However, advancements in energy storage technologies, such as improved batteries, have significantly mitigated the issue of intermittency. Additionally, a diversified energy mix that includes various renewable sources and smart grid technologies can help ensure a more stable and reliable power supply. Land use and environmental impact. Detractors of renewable energy often raise concerns about the large land footprint required for solar and wind farms, asserting that this leads to habitat disruption and other environmental issues. While it is true that some renewable energy projects may impact local ecosystems, proper planning and siting can help minimize these concerns. Furthermore, the environmental impact of renewable energy is generally lower compared to traditional fossil fuel extraction and combustion. The extraction and burning of fossil fuels contribute to air and water pollution, habitat destruction, and climate change, all of which pose significant threats to the environment. Manufacturing and resource depletion. Critics argue that the manufacturing processes involved in producing renewable energy technologies, such as solar panels and wind turbines, contribute to pollution and resource depletion. While it is true that manufacturing any technology has an environmental impact, studies indicate that the lifecycle environmental footprint of renewable energy technologies is generally lower than that of fossil fuel technologies. Moreover, ongoing research is focused on developing more sustainable and recyclable materials for renewable energy technologies, aiming to further reduce their environmental impact. Economic viability and affordability. Another criticism of renewable energy relates to its economic viability and affordability. Critics argue that subsidies and government incentives are essential for the industry's growth, suggesting that renewable energy is not economically competitive without external support. However, the cost of renewable energy technologies has been decreasing steadily over the years, making them increasingly competitive with traditional energy sources. The long-term benefits, such as reduced environmental externalities and improved energy security, often outweigh the initial costs. While critics raise valid concerns about renewable energy, it is essential to consider the broader context and ongoing technological advancements. The transition to renewable energy is a complex process that requires careful planning and consideration of various factors. Addressing the criticisms involves continuous research and innovation to improve the efficiency, reliability, and environmental sustainability of renewable energy technologies. Ultimately, a diversified energy portfolio that combines renewable sources with energy storage and smart grid solutions can provide a more sustainable and resilient energy future.